you've ever looked at a pepper and wondered, how much pain will this thing cause me? You've probably come across numbers like these. Scoville heat units. But where do these numbers come from, and what do they actually tell us? Like, if you have this pepper that's 2,000 Scoville and this one that's 300,000, well, that one's definitely hotter, 150 times higher on the scale, but is eating one of these like eating 150 of these? And why on earth would the scale max out at a number like 16 million? Well, let's ask Mr. Scoville himself. Wilbur Scoville was an American pharmacist born back in the 1860s. He was quite a successful and respected pharmacist, but he encountered a problem during one of his jobs. He realized that while hot peppers varied wildly in their pungency, even within the same variety, there wasn't a good way to quantify that or put it into numbers. Why was this relevant to a pharmacist? Well, hot peppers were often used medicinally at the time, and he had begun to work for a company that made a salve that you could use to soothe sore muscles. Now, you might think that would cause more pain and not less, but done properly, it can actually be pretty effective, and it's actually still sometimes done this way today, particularly for nerve pain. They'll apply a local anesthetic so that you don't notice the burn, and then put on a patch containing capsaicin, the main spicy chemical found in peppers. And apparently it's pretty effective. But to make something like that, or the salve our friend Wilbur was making, you need to be able to figure out how much pepper you need to make a given batch of a given strength. How are you supposed to calculate that when different batches of peppers aren't consistently spicy? So he devised what is now called the Scoville organoleptic test, a system that went something like this. Take your peppers, dry and grind them, take 1 grain of that, mix it into 100 milliliters of alcohol, let it dissolve out the capsaicinoids overnight, that is, capsaicin and several related spicy chemicals, and then filter out the pepper powder. After that, the tasting begins. You take this spicy alcohol, dilute it in lightly sweetened water, taste it, dilute it again, taste it again, dilute it again, and over until it's too diluted and the tasters can't detect the spiciness anymore. You average out the results from the different tasters, and that gets you your Scoville rating. Say the last dilution that the tasters could detect spiciness at was 1 part spicy alcohol to 50,000 parts water, then it would be measured on the Scoville scale at 50,000 Scoville heat units, or SHU. That may sound like ridiculously large dilution numbers, but for perspective, all you would need for that one is a bit more than 1/8 of a teaspoon of the alcohol in a 4-liter milk jug full of sweetened water. With hotter peppers, a little can go a long way. And so the spicier the pepper, the more capsaicinoids it contains, the more you will need to dilute it to stop tasting the spice, and the higher your number will be. This was a clever way to measure it at the time and stick concrete numbers on a subjective experience. Now you can say as you're making your salves, okay, this pepper is about 10,000 Scoville heat units, so I need about this many to make a batch of salve. But you might be able to see 2 significant problems here. First, it is a bit of a tedious test, especially if you have a lot of different peppers to taste. But second, and the bigger problem, who are your tasters, and what is their spice tolerance? I mean, I've met people who can down Scotch bonnets as if they're nothing, and I've met people who think that putting a pinch of black pepper in chicken noodle soup is a bit too spicy. See, capsaicinoids activate heat receptors in your mouth, making the sensors think they're perceiving actual heat and sending corresponding signals to the brain. But the more often you activate those receptors, the less sensitive they will get over time. So it takes more capsaicinoids to activate them the same way next time. And that's why if you enjoy spice, but your spice tolerance is low, and to you, maybe Frank's Red Hot Sauce is plenty spicy enough, you might look at someone who enjoys just eating habaneros and think, why on earth would they subject themselves to that? But it could very well be that when you eat Frank's Red Hot Sauce, and they eat habaneros, that it feels the same to both of you, that this guy just has less sensitivity. And those tasters determining Scoville ratings there, they could obviously be affected by this too. What if one taster stopped tasting that spiciness at around a 1 to 50,000 dilution, but another taster still tastes it at 1 to 200,000? Or what if the same taster is doing lots of tests back to back and progressively loses sensitivity over the course of that time? I mean, you try to average these things out in the tests to account for some of that, but it is still a problem. Fortunately, though, as new chemistry equipment was developed, a more objective measurement was figured out using high-performance liquid chromatography, or HPLC for short. This process uses some fancy machinery to separate and measure different chemical components of a liquid solution, giving you a measurement in parts per million. That is, if you had 1 million grams of this sample, how many grams of it would be capsaicinoids? Now, the results you get using this method don't quite match the results of the original Scoville organoleptic tasting test, but if you multiply your results by 16, it gets into the right ballpark. Some go 15, some go closer to 17, but 16 is a pretty common number to choose for this. So assuming 16, if you have a blazing hot pepper at, say, 1.6 million Scoville heat units like the Carolina Reaper, if you take that number, divide it by 16, you get 100,000, which means that 100,000 out of every million grams of that dried pepper are capsaicin, or 10% of its weight. That is a lot. That's a spicy pepper. That calculation is also why the scale caps out at 16 million. Pure capsaicin, meaning 1 million parts per million are capsaicin, times it by 16, you get 16 million. But the question arises, what do these numbers actually mean for me as a spicy food eater, and how comparable are they? And we haven't answered the question from the start either. Is one of these as spicy as 150 of these? Well, the answer to that one is not quite. That's not quite how this scale works. The capsaicinoid measurements are linear, but our taste perception of them are not. Not only would the sheer bulk and biomass of those 150 peppers dilute the capsaicin quite a bit and make it seem a lot more spread out, but also you couldn't even say that one pepper is 150 times more intense in its spiciness than the other one, because there's diminishing returns. The higher you go on the Scoville scale, the larger the increases you need to actually notice further difference. So sitting down and tasting a 1,000 and a 2,000 Scoville pepper should be pretty easy to notice the difference. Tasting a 71,000 and 72,000 Scoville pepper, same numerical difference, but you're probably not going to notice that difference. And sometimes the scale could be messed with if, for instance, one of the peppers had more oils or sugars in it than the other, which can interfere with our perception of those capsaicinoids. Like this pasilla pepper here might actually be higher on the Scoville scale than this particular jalapeno, but in the end might actually taste less spicy because it also happens to be sweeter than this jalapeno. And strictly speaking, scientists in these tests are usually measuring total capsaicinoids, but not all capsaicinoids are equally spicy, so different peppers might have the same total amount, but proportionally less of the spiciest ones. So anyway, no. Well, this has 150 times the capsaicinoid concentration. You can't really say this one tastes 150 times as hot. Not in a meaningful way that actually matches what you'll experience anyway. And to top off the confusion with this scale, 50,000 Scovilles for a pepper might taste a lot different from 50,000 Scovilles in a hot sauce. Because, well, the peppers in these two things have been processed very differently. This one, it's been diluted, but with vinegar and other things that might have positive or negative effects on the perceived heat. And also scientists speculate that when you filter out the solids in something like this, it may end up also filtering out more of the capsaicinoids than it would just a dried, ground up pepper. That, and there can also be marketing involved, so do take hot sauce Scoville ratings with a grain of salt. This one just says hot. I respect that. At this point, scientists haven't figured out any sort of direct, easily predictable relationship that will reliably tell you how much spicier this much more capsaicin will make something. But for now, well, it's not very precise and depends where you're measuring it. At least the Scoville scale is useful for giving us a rough ballpark on spiciness. It's at least a lot less subjective than just saying, well, anonymous Jim on the internet says this pepper is moderately hot, 5 out of 10. Who's Jim? What's his spice tolerance? Maybe Jim is a Norwegian fisherman with IBS who thinks that low-fat sour cream is maybe a little bit too spicy. Or maybe Jim is a Trinidadian grandpa who spends his afternoons in front of his pepper spray sprinkler that he uses to keep kids off his lawn. Like, who knows what Jim's tolerance is? And so who knows what his rating means for my particular experience? Interestingly, one study I read did talk about this difficulty in measuring and how the answer might be to measure the heat using electronic tongues that, well, I guess I'll just read the quote. They say, looking forward, we anticipate the widespread adoption of more advanced technological tools such as the e-tongue, e-nose/bionic electronic nose, and the incorporation of artificial intelligence/machine learning to examine chemesthesis and sensory profiles for pungent compounds like capsaicin. More research needs to be done to make these platforms smaller, cheaper, and more accessible for consumers and food scientists. There's something about including consumers in that I find amusing. Like, it conjures up this image of a futuristic society where every household has an e-tongue and an e-nose to pre-experience their food for them. Maybe the e-nose also tells you that you should probably shower before leaving the house. Probably not where they're going with that. If I run for office someday, that'll be my platform. An e-nose in every home. But speaking of digitally outsourced suffering, if you'd actually like to see me eat some of these spicy peppers and suffer the consequences, I am doing that for subscriber milestones. I've already done one where I ate a 10,000 Scoville pepper for 10,000 subscribers. You can find that one here. Next one will be 50,000. So, of course, subscribing, liking, sharing these videos, supporting me on Patreon or YouTube memberships, that will all help me get to the next milestone faster. In any case, thanks for watching and supporting me, and for more plant facts, join me next time on Ambling with Sam.